All right. So the next question asks us to find the dimensions of the rectangle of the largest area that can be inscribed in a circle of radius r. Okay, so what does it mean for a rectangle to be inscribed within a circle of radius r? Okay, so imagine that we had a circle with radius r here, okay? So it means that the rectangle is inscribed if the rectangle is within the circle. Okay, that's what it means by inscribed, right? So obviously you can find the rectangle of largest area and the dimensions of that rectangle by having the rectangle touch the vertices of the rectangle touch the circle. And by doing so, you can ensure that you will find the rectangle of the largest area and you can find those dimensions, okay? So basically, we're going to try to find the dimensions. So we're going to try to, first of all, find a function that defines the area of the rectangle in terms of the radius of the circle and in terms of the values of x or y. Okay? So looking at our diagram here, it is very clear that first of all, that the rectangle has to be touching the circle. Okay? So that means that the radius is also the diagonal, is half the diagonal of the rectangle, okay? And the diameter is the full diagonal of the rectangle, okay? So that means our height of the rectangle is going to be this, okay? So first of all, we're going to try to use Pythagorean Theorem here. So Pythagorean Theorem states that r squared is equal to x squared plus y squared, okay? So the hypotenuse of a right angle triangle is equal to the squares, the sum of the squares of their sides, right? So we're going to isolate for y here. So y is equal to r squared minus x squared. Okay. So looking at our diagram here, this is the length of y, right? And we see here that our rectangle, the height of the rectangle is going to be 2 times y, right? So there's 2 lengths of y here for our height of our rectangle. So the height, I guess the length, I don't know why I'm saying height. The length of our rectangle is going to be 2y, or 2 times r squared minus x squared. Okay, what about our width? So the width is going to be 2x, okay? So therefore, our area of the circle, right, what's the formula for area of a rectangle, sorry, is going to be width times length, right? But that's also equal to 2 times r squared minus x squared times 2x. Okay? And if we're to simplify this, it would be 4x times the square root of r squared minus x squared. So now we have found a function that defines our area of the rectangle in terms of the radius of the circle and also the dimension of the x value. Okay? And another thing is that this x value defines the length and the width of a rectangle. Okay? So now that we have found our function that varies the area of the rectangle based on the radius of the circle and also the x value, we can now optimize, like in our previous question, for the maximal area of this function. Okay, so we're going to try to find the maximum of this function. And to do that, we're going to, again, find the derivative of our function here and try to find the critical points. And if we find the critical points of this function, then we can find the maximum. Okay? And if we find the maximum, then we can find the dimensions of our length and our width. Okay? So that's the rationale behind all this thinking here. Okay? So, another thing to note is that the radius of our circle is going to be kept constant, and we're not going to be deriving in terms of r. Okay? Because that's not what the question is asking. The question is asking for us to look for the length and the width, and we know the length and the width is dependent on this value x. Okay? So, we're going to derive our function in terms of x. Okay, so we're going to use a chain rule here. So that means that we're going to derive this first function first, or not the chain rule, we're going to use the product rule, sorry. So we're going to use the product rule, we're deriving this first function first, so it's going to be 4 times the root of r squared minus x squared, and we're going to add it to the derivative of the second function, which is going to be half of r squared minus x squared to the power of negative half. Oops, that's not a 1. Times the derivative of the inside function, which is going to be negative 2x. Okay? Did I forget anything? Oh, and times 4x. Okay, so if I were to simplify this, we would get 4 times r squared minus x squared minus 8x squared divided by, or minus 4x squared divided by the root of r squared minus x squared. And if we were to simplify this further, we would find that this would equal to 4r squared minus 8x squared divided by the root of r squared minus x squared. Okay, so you guys can pause the video and you guys can simplify this, but basically I moved everything under the same denominator by multiplying this first term by square root of r squared minus x squared, and then I simplified to find this derivative function. Okay, so now we're going to set this derivative to equal to 0, because we know that a critical point relates to either a maximum of our function, a minimum of our function, or a saddle point. Okay, so if we set this equation to equal to 0, we notice here that this is a rational function, right? So to set this equation to equal to 0, all we have to do is to find the value of x, which will make the numerator equal to 0. And that's what we're going to do. So 0 equals 4r squared minus 8x squared. And if we isolate for x, we get 8x squared equals 4r squared. We have x equals the square root of r squared divided by 2. Okay, maybe I should explain this further. We have x squared equals 4 divided by 8r squared, and we have half r squared. And then we have root both sides, and we have r divided by 2. Root of r divided by 2. Okay, so this is the value of x, which will basically maximize or minimize our function here. Okay. Now, we want to understand here that this critical point here is going to maximize our function here, and that's because of the nature of our function. Okay. This is a square root function multiplied by a variable of x, and we know that there's only a maximum of this function, and the minimum of this function does not exist. Okay, so with that in mind, we can now consider this value of x to be maximizing our area of a rectangle, and by doing so, we can now find the dimensions of such a rectangle. Okay, so if x is equal to the square root of r divided by 2, then the width, which is equal to 2x, is going to equal 2 times the root of r divided by 2. Okay, and the length is going to equal 2 times the square root of r squared minus, what's length equal to again? Minus the r minus the r times the root of 2 divided by 2 squared. Okay, so if we were to simplify for this, we'll get 2 times r squared minus 2r squared divided by 4, and we would get 2r squared minus r squared divided by 2, and we would get 2r squared divided by 2. Okay, and if we keep going with this, we would get 2r times root of 2 divided by 2, and we will get r times root 2. Okay, so these are the dimensions that will maximize the area of our function according to the function that we have derived based on using the Pythagorean theorem and also using our area formula, right? So by optimizing this function and by finding the critical point of this function, we're able to identify the dimensions and where the largest rectangle, or the largest area rectangle exists within the circle. Okay, and the dimensions of that is width is 2 times root of r divided by 2, and our length is r times root 2. Okay. Wait, sorry. This is, I think my x is wrong actually. Now I'm looking at it. X should be sorry. So this is actually wrong. This should be 3 times r root 2 divided by 2. This equals r times root 2. Okay? Alright, so the solution is correct and we can move on.